In this video, you can see how buffers can be used as intermediate stations between two processes to reduce the blocking and waiting times of stations. To get started, we use a model with two stations, a source and a drain. To show you the advantages of a buffer, we need to set two different processing times for our two stations. If we set the processing time of station 2 much higher than station 1, for example to 1 minute while station 1 has a processing time by 10 seconds, we see that station 1 is finished much earlier and must wait until station 2 has processed its part and forwards it to the drain. To avoid these blockades, we can insert a buffer between our two stations. The first station can produce now without waiting for the second station to finish. In the buffer dialog, we can set the capacity and choose a buffer type. Buffer type Q works with the principle first in, first out, so the parts exit the buffer in the same order in which they entered it. In the stack type, the part which entered last leaves the buffer first. Select the Q type and set the capacity to 15. Now set the processing time of station 2 to 30 seconds. Then run the simulation. As you can see, the buffer fills up gradually and ensures that station 1 can continue to produce in the same rhythm without delays. For more information on the buffer, you can have a look into the online help. If you want to sort your MUs according to certain criteria, a sorter can be used instead of a buffer. The sorter sorts the MUs located on it according to sort criteria, which you define. The exit sequence of the MUs depends on the priorities you set. The sorter moves the part with the highest priority first, regardless of the time at which it entered. To showcase this, we replace the buffer with a sorter and open its dialog. You can set the capacity, the order, time of sort, and the sort criterion. When you select a descending sort order, the sorter moves the part with the highest value first. When you select an ascending sort order, the sorter moves the part with the lowest value first. You can choose occupation time as criterion. Then Plant Simulation sorts the MUs according to the time they remained on the sorter. To define your own operation mode, select the setting method. In this video, we will show you a simple example for MUs property as a sorting criterion. Select Descending as order and choose MUs property as sort criterion. We will use the length attribute to sort the MUs. Now open the source dialog and set the MUs selection to sequence. Place a data table and open it. To show you how the sorter works with the sort criterion attribute length, we let our source produce two different types of parts, a normal part and a container which is longer than the part. Enter 2 for each object, close the window, and set the amount of the source to 4. Now start the simulation with a slower simulation speed. As you can see, while the first part is processed by the second station, the sorter sorts the objects according to their length. The two containers are passed before the second part, because we have chosen descending as the order. This video showed you how to work efficiently with the buffer and the sorter to reduce blocking and waiting times of your plant.